Okay, so welcome to our first day of chapter 15, inverse trig functions. I think today is one of the most important days just to get an intro to what we're going to be doing in this chapter. So let's go ahead and move on to the next slide. Of course, it's the length of day lab. If you have any questions, you need to communicate with me soon. Check Schoology for due dates. So here we go. Introduction to our trig unit. A lot of the work that we've done in unit circle is going to show up here. So just to start right away, tangent of what radian is going to give us 1? There was a couple questions like this in our last test. I would say the first place that you get 1 would be at the radian pi over 4. Tangent is sine over cosine. That'd be root 2 over 2 over root 2 over 2 at pi over 4. That's equal to 1. Now, that's not the only place that that's true, but that's the first place. You could also make an argument for something in the third quadrant. Okay, so what we are going to be working with in this chapter is this notation. Inverse tangent of 1 equals x. It's saying kind of the same thing. What x value, when you take the tangent of it, what radian are you going to get 1? Same answer is still x equals pi over 4. Okay, the other notation that you can see for inverse tan is arctan. I've seen this in calculus. I've seen it both ways. So you could also see the arctan of 1 equals x, and so you would say x equals pi over 4. So let me highlight this notation and this notation are exactly the same thing. One is in your calculator, that actual button's in your calculator, and the other one's not, but they mean exactly the same thing. Okay, so what does it mean? Arc cosine of 0.5 equals x. That means what radian results in cosine of x equaling 1/2. Where do we find that? And the first place that we would find that is at pi over 3. Now, there are some restrictions on our answers, which we're going to get into, not in this slide, but coming up. So let's try it again. Cosine of x equals negative 1/2. Where's the first place that happens? I would say the first place that happens is at 2 pi over 3 in the second quadrant. Again, same thing. You could also see arc cosine of 1/2 equals x. They both mean the same thing. You'd also get 2 pi over 3. Okay, now I like this bottom part. This is a composite expression. Think of this section as theta. So at the very end, I'm going to say the cosine of theta equals what? Well, we have to figure out what theta is. So I am given a clue that I know that whatever theta is, this is the theta we're looking for, that the sine relationship is opposite over hypotenuse. So the opposite of hypotenuse is 3 and 5. I'm going to guess that this is a 3, 4, 5 triangle, so that other leg is 4. So no matter what theta is, I don't know what it is, but the relationship, the cosine of theta, according to this triangle, is 4 over 5. Okay, so you're going to see that kind of problem pop up again in these slides. So I went ahead and I added a page. I'll give you a second to add a page into your Notability. The slides needed one more page. So I am going to graph a sine function. So y equals sine x, and I'm just going to draw a quick little sketch of sine x. Okay, so if you look at sine x, first ask yourself, is it a function? Does it pass the vertical line test? And I would say yes. For every 1x, there's 1y. And then ask yourself, does it pass the horizontal line test? If I were to draw a horizontal line through this function, would I only touch it at one place? And I would say the answer is no. It fails the horizontal line test. Okay, so that matters when we're dealing with inverses. for inverses, for every one x, there should be one y, and for every one y, there's one x. Well, that's not the case here. So what we need to do is we need to do something called restricting the domain. And this is standard for each one of these functions. You don't actually have to figure out what the restrictions will be. I will tell you what they are. In this case, we're going to restrict sine from negative pi over 2 to pi over 2. So if I were to do that, restrict it from negative pi over 2 to pi over 2, I'm left with that function. Does that pass the horizontal and vertical asymptote, the vertical and horizontal line test? It does. So it's 1 to 1. So for every one x, there's one y, and for every one y, there's one x. So inverse sine is between negative pi over 2 to pi over 2. Negative pi over 2 to positive pi over 2. On the unit circle, that would be from 0 to pi over 2 and from 0 to negative pi over 2. And I'll show you why that matters in a second. Okay, so let's take a look at cosine. Cosine looks like this. Okay, does that pass the vertical line test? Yes. Does it pass the horizontal line test? No, it doesn't. Okay, so what I'm going to do for cosine is I'm going to restrict cosine from 0 to pi. From 0 to pi, now we're going to restrict the domain, so now I'll redraw it so that I only have 0 to pi, and that is now 1 to 1. For every one x, there's one y, and for every one y, there's one x, which means that cosine, inverse cosine of x, is between 0 to 2 pi. Okay, so if I were to draw a picture of that, inverse cosine of x goes from 0 to 2 pi. Okay, last one, if I were to graph tangent, one tangent would be fine. Many tangents are not going to pass the horizontal line test. Okay, so we are going to restrict the domain, so that when we restrict the domain, we are going to be the same as sine. So we are going to be from inverse tangent of x, how did I say this before, is between negative pi over 2 to pi over 2, so that I can get one answer for the inverse. And you'll see on the unit circle for tangent, it's just like sine. It goes from 0 to positive pi over 2 and 0 to negative pi over 2. Okay, let's go to the next slide that's in the slides. So let's graph what these actual inverses look like. So if you remember, to graph an inverse, you switch the x and y. Well, in this case, I'm going to go ahead and switch the x and y axis. So I know on sine usually goes from -1 to +1 on the y. Now it goes from -1 to +1 on the x. So I'm going to say the domain goes from -1 to +1. And if you remember, we restricted sine from negative pi over 2 to positive pi over 2. And if you were to replace the x and the y, if you were to switch them, your inverse function looks something like that. So that your range goes from negative pi over 2 to positive pi over 2. Okay. Cosine, once again, -1 to 1. If you remember, cosine, though, was restricted from 0 to pi. So when I graph this one, it looks somewhat like that. Okay? Kind of a terrible drawing. Domain is from -1 to 1. Range is from 0 to 2 pi. Okay? Last one is tangent. If you remember, we went from negative pi over 2 to positive pi over 2 on the x-axis. Now that's on the y. And that's where our vertical asymptotes were. Well, now that's where our horizontal asymptotes are going to be. Okay, and then when we graph tangent, it's going to look somewhat like this. So the domain is all real numbers. The range used to be all real numbers. You just go up and down forever. Now that's your domain. And your range goes from negative pi over 2 to pi over 2. Okay. Ms. Eichler, how much of this do I need to remember? Here is the most important part, and I'll draw it down at the bottom. And I've drawn it once before, but you need to know that if you are finding the inverse value of a sine function, you are only allowed to give answers in the first and fourth quadrants. Okay, same with tangent. Tangent is going to be exactly, and you don't have to draw it twice if you don't want to. I'm not really sure why I am. Tangent goes from negative pi over 2 to positive pi over 2. Cosine, you have to remember this is the hardest part. Cosine is only available in quadrants 1 and 2. Okay, the other thing that you have to remember is that if you are going in the positive direction, that's positive theta. But if we're dealing with a graph, this direction, this way, like if it, let's say it was 5 pi over 3 in our old life, now it's just negative theta. And I'll show you what I mean, but you have to think about it in terms of a graph, going to the left and going to the right versus finding the answer on the unit circle. Again, tangent is going to be positive theta and negative theta answers. Cosine is only going to have positive theta answers. Okay, so let's dig right in. Number 1, what is the inverse sine of root 3 over 2? So we're going to cheat a little bit. We've got our unit circle here now that we're just starting out. So inverse sine of root 3 over 2. So it's positive, so it must be in the first quadrant. And we're looking for where the y value is equal to root 3 over 2. And I see that it's right here at pi over 3. Positive pi over 3, I don't have to actually write positive, so I'm just going to say my answer is pi over 3, or 60 degrees. Okay, inverse cosine of negative 1/2. That must be in the second quadrant. Where's my pointer? So where is the cosine? Where is the x value equal to 1/2? Here our x value is equal to negative 1/2. That's happening at 2 pi over 3. So I'm going to write 2 pi over 3 in not highlighter. Okay, where is tangent equal to 1? This was kind of our opener today. Tangent is equal to a positive 1 here. Now, I'm not saying here as well. It is equal to positive 1, but that's outside of the domain of inverse tangent. Inverse tangent only lives here, which means the only answer is pi over 4. Okay, last one of this kind. Where is inverse sine equal to 1? Where is the y value equal to 1? You can have one of the axis values, but I want the positive one. So inverse sine equal to 1, this one's negative 1, so I'm going to pick this one, happens at 90 degrees or at pi over 2. So these are the composition of trig functions that we briefly talked about at the beginning of the lesson. So if you take a look at the first one, each one of these is most likely going to require you to draw a little triangle. So we have first the inverse cosine of 4/7. Remember, we're just looking to figure out that's a theta. We aren't going to figure out exactly what that theta is, but it's going to help us figure out the trig ratio for sine. So it's saying that this theta has a cosine ratio of 4/7. Okay, I need to use a little Pythagorean theorem. 49. So I think b is the square root of 33. Okay, if b is the square root of 33, that means that the sine, I'm going to get rid of my work because now I can't, I've run out of room. That means the sine of theta, I have theta in my triangle, so the sine of theta is opposite over hypotenuse, which is root 33 over 7. Let's try it again. Arc sine, which of course means the same as inverse sine, of negative 1/3. So let's start by drawing that. So I have sine, negative must mean that it's in the fourth quadrant. Remember, it can only be in the first or the fourth. Opposite over hypotenuse. I did my opposite is -1. And then I would need to figure out what that missing side is. If you do a little Pythagorean theorem, you get the square root of 8. And then I need to know tangent of that theta is going to be equal to what? Well, tangent is opposite over adjacent, so I get -1 over the square root of 8. And I'm okay with you not rationalizing it. Okay, last one. So we've got the cotangent of x. We don't actually even have, ooh, these are a little harder. We don't actually even have a value here. All I can do is know that x is the same as x over 1. Okay, so let's graph this. And it's positive. So cotangent, inverse cotangent of x. Well, tangent is opposite over adjacent, so this is adjacent over opposite. Okay, then I'm going to do Pythagorean theorem equals, we'll call it c squared for hypotenuse. So I end up with c equaling the square root of x squared plus 1. So when I try to figure out cosine of theta, I've never figured out what the actual theta is. I just want to know what the cosine relationship is for theta. Cosine theta is adjacent over hypotenuse, x over the square root of x squared plus 1. So you're going to see more of the same here. If you use a calculator, you get them all. But we are definitely going to have problems that will have square roots, and if you answer in a decimal, you'll know that the jig is up, that you're using a calculator to answer them. So make sure that you know how to do them without a calculator. Oops, I'm on the next slide. Okay, we're going to, I don't think this is as important as our day 1 problems. I would not skip these. I would do all of them. I'm going to pick a few to do with you. Why don't we do like number 22? So the arctan of 0. What is the inverse tangent of 0? Where is tangent equal to 0? Well, we have to remember tangent is sine theta over cosine of theta. Where is that going to give me 0 over 1? What axis value is going to do that? And I think that's where x equals 0, pi. You could also say x equals, we normally say 0, so I would take either of those. It has to be in quadrant, between quadrant 1 and quadrant 4, and the only place that happens is at 0. We could also do the one above it, arc cosine of -1. So where is cosine equal to -1? Between -pi/2 to pi/2. And I think that that's, I'm sorry, cosine, it goes from 0 to 2 pi. So where on this circle is cosine, the x value, equal to -1? And I would say that's right here at pi. Now you don't have to show any work for these. If again, if you are fairly good at the unit circle, you should do an okay job with this. Like number 3, what gives you -√2/2? So you know what value of sine, what radian, when you take the sine of that radian, you get √2/2, it's pi/4. Now, this is arc sine, so if it's negative, your answer is going to be -pi/4. No work needed, okay? Arc cosine, however, -√2/2 is in the second quadrant. Inverse cosine is defined between quadrant 1 and quadrant 2, so it is okay to say that this one is 3 pi/4. Remember, cosine is defined here and here, so all answers are positive, but sine is only defined in quadrant 1 and quadrant 4, but in quadrant 4, that's a negative theta. So to get to this place in quadrant 4, you have to go -pi/4. Just trying to, don't say positive 7 pi/4, because if you think about the graph, positive 7 pi/4 is outside of that picture. Okay. Gold, I would recommend doing. We're going to open up the next class period, so I'm not going to see you. We've got some days off of school. The next time I see you will be the 5th or the 6th. We will open that day with Schoology quiz for inverse values. So between now and that time, if you need some practice problems or if you need help with the homework, please contact me. I can't tell you enough how important I feel like this chapter is, or this unit is. in terms of unlocking the rest of the unit. I hope you're having a good sunny day. Bye. Let's do a few more. Let's take a look at 61's a little strange. Take a look at that one. It says arc sine is 5/4, positive 5/4, opposite over hypotenuse. That can't be, and I'm hoping you're looking at that thinking, yeah, that's not possible. If you don't see it, you'll do the Pythagorean theorem and you'll think that you might actually get a value, but hypotenuse has to be the biggest number, right? And if you put that in your calculator would say no way. This one is it does not exist. That triangle doesn't actually work. So let's skip that one and let's do 91. This is a composite. It's actually done, it's not quite the same one that we had on the last slide, so I'm glad we're doing this. So first we're going to go from the inside out. Sine of 4π/3. Well, that's not an inverse. That's just a unit circle question. The sine of 4π/3 is what? Negative root 3/2. So then I'm going to rewrite, what is the arc sine of negative root 3/2? Okay, so to get the sine of root 3/2, it's π/3, right? But it's negative. We have to think about doing it in quadrant 2 with a negative theta, so it's going to be negative π/3. And then this yellow slide, these are a little tougher. These, I feel like, are the honors pre-calc questions. Okay, so I'm hoping that you can see, like, I'm going to do, I know that I'm picking one that's not one in your list, but I'm going to pick 171. I see, if this is representative of a theta, I'm going to rewrite this as a sine, 2 theta. And my hope is that you recognize that as a Pythagorean identity, or a trig identity, rather. That's the same as 2 sine theta cosine theta. That's back from our beloved trig identity chapter that we haven't had in a while. Okay, so it's arc cosine of x. We just did a problem like this. Remember, that's like x/1, and it's cosine. So cosine is adjacent over hypotenuse. And if you did Pythagorean theorem, and I'm just going to tell you, it's going to let me erase. There we go. I ran out of room. That if you did the Pythagorean theorem, this would be, what would it be? 1 minus x squared. So then we're going to use those values to figure out sine theta and cosine theta. So sine theta would be opposite over hypotenuse, so it would be 2 times the square root of 1 minus x squared over 1. And cosine theta is adjacent over hypotenuse, so x/1. And that would be your final answer. So these are a little bit more challenging, I feel like. Let's try one more. Let's do 172. Cosine of 2 arc tan x. 2 arc tan x represents a theta, so that's the same as cosine 2 theta. There's there's 3 identities for double angle for cosine. I think I've said more than once that my favorite is this one, cosine theta minus sine squared theta. So I'm going to build the triangle. Once again, we've got x/1. Tangent is opposite over adjacent. If you did Pythagorean theorem, you get x squared plus 1 is the hypotenuse. So you're going to have 1 over, adjacent over hypotenuse would be 1 over x squared plus 1 squared minus, sine would be opposite over hypotenuse squared. And then you can easily square everything. So the top of the first fraction, again, I don't have notability, so I can't shrink anything, but the top would be 1, and the bottom, the square root would fall off, and you're left with x squared plus 1. And then you could square the x in the second fraction and take off the square root, and then you have a final answer of 1 minus x squared over x squared plus 1. I think these are fairly challenging. But anything that's your homework tonight is to do everything in the circles. So you can do the challenge or not, it's up to you.